Number 1 asks us to identify a solution to this system of equations. So remember that our ordered pairs are written with our x-coordinate first and our y-coordinate second. And in order to be a solution of the system, they have to work in both equations or all equations of the system. So we're going to plug these into both the top and the bottom equation and see which one satisfies both. So we'll do -4 times the x plus 3 times the y and see if that equals 23 for that top one. And we'll also take the x and we'll subtract the y and see if that equals -7 in the bottom equation. So the first one had -5 for the x and had 2 for the y. So that's +20 and then +6, which does not equal 23. So this one cannot be a solution because it's not a solution to the first equation. So then we'll switch out and we'll work on the second one. So we'll plug -2 in for x and we'll plug 5 in for y. -4 times -2 is 8. 3 plus 5, or 3 times 5 is 15. 8 plus 15 does equal 23, so it's a solution to the top. So then we'll plug it into the bottom. So we have the x minus the y, and -2 minus 5 is -7. So it's a solution to the bottom one as well. And then we know that we can stop here because these can't be solutions because these two equations are lines, and lines can only ever intersect at one point. So if we found one point that's on both lines, then no other points could be that point. So we don't even have to check C or D. Number 2, Lynn is solving the system of equations. She starts by rearranging the second equation to isolate the y variable. She then substitutes the expression for y in the first equation as shown. Check to see if this solution makes sense or makes both equations true. So we'll just plug it in here. And so when we do, so we'll do 6 times -36 and then -5 times 58 and see if that equals 34. Well, 6 times -36 is -216. And then -5 times 58 is -290. And so that for sure does not equal 34. So no, this does not make the equation true. That means that Lynn must have done something wrong in her work. So then we want to find that. Okay, so where did she make a mistake? So let's take a look when we're looking here. So she isolated the one equation and got 4 minus 1.5, and she's just plugging it in here. So that looks fine. And then when she moves to this step, so she should be doing -5 times 4, which is -20. Then she should be doing -5 times -1.5. So this part should have been positive 7.5. When you do a negative times a negative, we should have gotten a positive here. So then when she did 6 plus 7.5x instead of 6 minus, this would have been 12.5x here, and that would have changed the solutions. So what she did was forgot that -5 times -1.5x equals positive 7.5x, or she missed distributing in that negative. Number 3, solve each system of equations. So we see here that we have x equals 4. So that means wherever we see x, we can plug in 4. We can just substitute that in. So on this top part, we'd have 2 times x minus 4y equals 20. And now we know that x equals 4. So we'll just plug it in. So then we end up with 8 minus 4y equals 20. 8 and 20 are like terms, but they're on opposite sides of the equation. So we'll subtract 8 so that we get 0 here. So this is just negative 4y. And then 20 minus 8 is 12. So then we can divide by negative 4, and I'm just going to move up here. So divide by negative 4, and we get y equals negative 3. So then when we write this together as a solution, we would have the x coordinate, which was 4, and the y coordinate, which was negative 3. So this would be our solution. Then for part B, we see that they already have y by itself. So we'll just take this and we'll plug it in here for y in this bottom equation. So the bottom equation says 2x minus 3 times whatever y is equals 7. And in this case, we know that y is 6x plus 11. So then we can just start simplifying here. So now don't make the same mistake Lynn made. We've got this negative 3. So we're going to have 2x. Negative 3 times 6x is negative 18x. And then negative 3 times negative 3 times 11 is negative 33. And then this equals 7. So we've got like terms here. So we've got 2x's minus 18x's. So we have negative 16x overall. Minus 33 equals 7. So the negative 33 and the 7 are like terms, but they're on opposite sides of the equation. So we want to zero this one out. So negative 33 plus 33 gives us 0. And negative 16 plus 0 is just the negative 16x. 7 plus 33 is 40. So then we'll divide by negative 16 to both sides. And we get that x equals negative 2.5. And I'm not going to box that in actually because we need to find y first. So now we've got our x. So then we want to go back into this y equation, okay, this top equation, and we want to plug that in. So we have y equals 6 times x plus 11. And now we found out that our x is negative 2.5. So then 6 times negative 2.5 is negative 15. And then plus 11. So our y value is negative 4. And then we can just write our solution. Our x value is negative 2.5 and our y value is negative 4. Remember, we write it as an ordered pair because it's the place that these two lines are going to cross. It's the ordered pair where these two lines cross. Number 4, Han is trying to solve this system by substitution. The first step is to isolate the x in the first equation to get x equals negative 5 minus 3y. Han's first step, so that was Tyler's first step. And then Han's first step is to isolate the 3y in the first equation and get that 3y equals negative 5 minus x. Show that both first steps can be used to solve the system and will yield or get the same solution. So let's take a look here at Tyler's. So Tyler solved this first one for x, right? So now we're going to plug it in the bottom one for x. So we're going to do 9 times his x value, which was negative 5 minus 3y. And then add 3y equals 3. And let me use some color actually so that we can see this a little bit better. So that initial equation was 9 times x plus 3y equals 3. And then Tyler's x value that he got was negative 5 minus 3y. So he's just plugging in for that x right here, right? So then we'll multiply this out. So we get negative 45 when we do 9 times negative 5. And then we'll do 9 times negative 3y, which is negative 27y. And then we still have plus 3y equals 3. So then we'll combine these like terms here. So we have negative 27 and positive 3y which is negative 24y, and then equals 3. Negative 45 and 3 are like terms, so I'll add 45 to get it to the other side. So we get negative 24y equals positive 48. So we'll divide by negative 24, and we get that y equals negative 2. Then we need to go ahead and plug negative 2 back into our top equation, or really the equation that Tyler did. Okay, so this one. So we'll plug this back in to get our x value. So we get x equals negative 5 minus 3 times y, and we got negative 2 for y. So then we get negative 5, and then negative 3 times negative 2 is positive 6. So we get x equals 1. So our solution here was that x equaled 1 and y equaled negative 2. So that's doing it Tyler's way. So if we go over and we do it Han's way, so his first step was that he just isolated the 3y. And when we just isolate the 3y, that's fine because we see the 3y here. So we can just substitute in for that whole thing. So when we go to that equation and we have 9x plus 3y, so whatever 3y is, equals 3. Now Han figured out that 3y is equal to negative 5 minus x. So we'll just substitute that in for all of 3y. Then we can just combine like terms. So we have 9x minus 1x is 8x. And then we have that negative 5 and then equals 3. So we can add 5 to both sides. So we get 8x equals 8. Then you can divide by 8 and get x equals 1. Then we just need to plug in to find y. So you can plug into Tyler's equation here. So he got 3y is equal to negative 5 minus x, which we know is 1. So 3y equals negative 6. When we add negative 5 and negative 1, then divide by 3, and we get y equals negative 2. And we see that we get that same solution. So we got an x value of 1 and a y value of negative 2. So both ways to complete that equation are valid. Number 5, the dot plot shows the distribution of the length in centimeters of 25 shark teeth for an extinct species of shark, and the length in 25 shark teeth for a closely related shark species that's still living. So we've got the extinct species on top and the one that's still living on bottom. And then they tell us the mean and the standard deviation of each set. So this just wants us to compare the two dot plots using the shape of the distribution, the measures of the center, and the variability. So use the situation described in the problem in your explanation. So this is just trying to get us to see, and let me make this type a little bit smaller so that we can see it a little bit better. So we see that both species have a sort of bell shape. Okay, so they have a shape that is close to a bell shape or similar. But the extinct species, so the extinct species had a 3.02 centimeter mean, and the living species has 2.32. So the extinct species, the size, but the extinct species had slightly larger typical size. And then they were a little bit more spread out, right? So they had a 0.5 standard deviation, and you can see that here. You can see it spread further. It's going from like 2 to 4, where here we're like 2.1 to 2.6. So the living species is much smaller spread. So the extinct species had a slightly larger typical size with more variability in the size. And obviously your explanation could be different than that, but that's just an idea of what it could be. Number 6, Kieran buys supplies for the school's greenhouse. He buys F bags of fertilizer and P packages of soil. He pays $5 for the fertilizer, $2 for the soil, and he spends a total of $90. So this equation here describes this relationship. If Kieran solves the equation for P, which equation would result? So if we look at this before we even get started, A isn't solved for P, it's not by itself. So A is going to be wrong right away. Then we can go ahead and just take this equation and start solving it. So we can subtract the 5F so that we get the 2P by itself. And so then we get 90 minus 5F. So A was the right first step. But now to get P by itself, we need to divide everything by 2. So 2P divided by 2 is P. 90 divided by 2 is 45. And then negative 5 divided by 2 is negative 2.5 for F. So we see that here in part C. And part B is close, but they had these switched around, right? So this should have been 90 minus 5F on top and then divided by 2. Then that one would have been fine. So you could leave it without dividing by 2. In this case, the answer, well, without actually calculating the division by 2, you could leave it as a fraction like this. But this answer just actually did divide the numbers. Number 7, Elena wanted to find the slope and y-intercept of the graph of 25x minus 20 equals 100. She decided to put the equation in slope-intercept form. Here's her work. She concluded that the slope is negative 5/4 and the y-intercept is 0.5. What was her mistake? So she did something wrong. So it looks like she subtracted 25x from both sides, right? Which is fine. She can do that. Then that zeroes this out, right? But there's still this negative that she didn't take into account. So she lost that negative. So this should have been negative 20 in front of here. So we should have had negative 20y equals 100 minus 25x. So then she would have been dividing by negative 20 to both sides. So she would have y equals negative 5, and then this would have been positive 5/4 x when simplified. So her slope, so her mistake was she lost the negative in front of the negative 20y. And then her slope is actually positive 5/4. So the slope is actually positive 5/4. And the y-intercept was negative 5. So it should have been 0, negative 5. Number 8, find the x and y intercepts of the graph. So remember that we've kind of got two forms here. So if we're in slope-intercept form where it gives you the starting intercept and then also gives you the slope. So if we're solved for y, that constant is our y-intercept. So we see that here. So we already have the y-intercept in this case. And so our y-intercept is going to be 0, 10 in this case. So then we just need to solve for the x-intercept. And remember, whenever we're on the x-axis, the y-coordinate is equal to 0. So anytime you're on this x-axis, right, all of these points have a y-coordinate of 0 because you haven't gone up or down any. So if you're on this axis, y equals 0. So then we'll just plug in y equals 0. So to find the x-intercept here, we'll do 0 equals 10 minus 2x. So I'm going to add 2x to both sides. So then we get 2x equals 10, divide by 2, and we get x equals 5. So then writing it as an ordered pair, that would be the ordered pair 5, 0. So y-intercept 0, 10, x-intercept 5, 0. So now if you're on the y-axis, so anything on the y-axis means that your x-coordinate is 0 because we haven't moved left or right. So if we're on the y-intercept, our x value is 0. So here, when it's in standard form, it's kind of, in my opinion, easier to just think, like, I wouldn't solve it for y. So I would just plug 0 in for x, and then that's just going to zero this whole thing out. So then we just get 4y equals 18, divide by 4, and we get y equals 2.5. So then, sorry, 4.5. So y equals 4.5. And so then that's going to be 0, 4.5. So that's your y-intercept. And then when we go to find the x-intercept, the same idea will hold true. So we'll plug in 0 for y. So we just get 9x equals 18. So we'll divide by 9, and we get x equals 2. Written as an ordered pair is going to be 2, 0. C is in standard form as well. So then we can just plug in 0 for x, which is negative 2y equals 44. Divide by negative 2, and you get y equals negative 22 for your y-intercept. So the ordered pair would be 0, negative 22. Then for the x-intercept, we'd plug 0 in for y. So this would be 0. So we would just get 6x equals 44. So then we can divide by 6 here, and we get x equals 7.33. So then as an ordered pair, that'd be 7.33 comma 0 for that x-intercept. Then this bottom one is kind of a mishmash. It's not in slope-intercept form, and it's not in standard form, but we can still do the same ideas here. So for the y-intercept, we'll plug 0 in for x. So then this is just going to say 0 equals 4 plus 12y. So then we'll solve for y. So I'll bring the 4 over. So it's negative 4 equals 12y. Then we'll divide by 12. So we get that y equals negative 1/3, or if you want to do it as a decimal, you can do negative 0.33. So then the ordered pair would be 0, negative 0.33. And then for the x-intercept, we'll plug 0 in for y. So we get 2x equals 4 plus 0, because we're putting 0 in here. So then we'll just divide by 2 and get x equals 2. Number 9, Andre is buying snacks for the track and field team. He buys A, pounds of apricots for $6 a pound, and B, pounds of dried bananas for $4 a pound. He buys a total of 5 pounds of apricots and dried bananas and spends a total of $24.50. So let's write an equation that represents this. Now, I like to look at these totals. So the total is 5 items that he bought, and the total money that he spent is $24.50. So total means I'm going to add something together to get those. So when I look at my equations, I want to see that they're equal to those two numbers. So I can rule out C and D because they're not equal. Like this one is equal to 4B. This is fine. Okay, this one's equal to 4 and 2450. So that's not what we want. So I can rule out some options. Then when we look here, we want the money going with 2450. So we want this to be $6 per apricot, and $4 per banana is going to equal that 2450. So we want to multiply 6 times the number of apricots and 4 times the number of bananas that we buy, and we see that in B. So the number of apricots plus the number of bananas is 5, and the money we spent on apricots plus the money we spent on bananas equals the 2450. Number 10 gives us 2 equations, and then it asks us to do this without graphing technology. So it wants us to find a point that's a solution to equation 1, but not to equation 2. So we want to look here. So I'm just going to put 0 in for x. And if I do that, I get 8 for y. And then we can plug that in here to check. They want it to not be a solution to this one. So if I do 2 times 0, that's 0. And -8 does not equal -6. So it's not a solution to the second one. So that's a point that's just a solution to equation 1. And then it wants us to find a solution to equation 2 that's not a solution to 1. So maybe we'll just do the same thing. I'll plug in 0 for x. So if I plug in 0 for x, we get -y equals -6. So then divide by -1 and we get y equals 6. So this one, the 0.06 is a solution, which obviously isn't a solution to the first one because when we plug 0 in, we get 8. Now it wants us to graph the 2 equations. So I'm going to go back to equation 1. I'm going to plot the point. Well, I can't plot the 0.08 because it's off the graph. So let's plug in another number to equation 1. So let's plug in, and it's just going to keep getting higher over here. Like if I plug in 1, it's going to be 11. So that's going to be off the graph. So let's plug in a negative number. So for this one, I'm going to plug in like -2. And so when I do that, and I'm plugging that into 3x plus 8. So 3 times -2 is -6 plus 8 gives me 2. So the point -2, 2 is on this graph. If I plug in -1, we're going to get 3 times -1 plus 8. So this is going to be -3 plus 8, which is 5. So at -1, we're going to be at 5. And then you can kind of see the slope here, right? So let me get this line, and you could use a ruler for this as well. But then you see the slope, right? The slope was 3. So this is down 3 over 1 to get to that next point. So I could go down 3 over 1 to get the next point, down 3 over 1 to get the next one. And then you have your line. So you'd have a point here, and you'd have a point here. And then you can extend this. So then we want to graph the second one. And so you could solve it for slope-intercept form if you want to graph it, or you can plug in the table. This one, the y-intercept was just too high, so I couldn't do it there. So if we take this second equation, let's solve it for y, because we see we can actually get the y-intercept because it's at 0, 6. So we'll subtract 2x from both sides. And then we'll divide everything by -1. So that'll flip this to +6 and plus 2x. So we see that the slope is 2. So from this point, we can get a slope of 2. Okay, and it's going to be a +2. So when we go down 1, we need to go to the left. Or when we go down 2, we need to go to the left 1. So down 2 over 1, down 2 over 1. So we have this positive slope happening here. And that will get us all of the points here, so we can plot that one. And then it wants us to find a point that is a solution to both equations. And when you probably saw when I was going down 2 over 1, we landed in the same spot here. So the point -2, 2 is on both equations, meaning that it's a solution to this, it's a solution to both.